I'm Robert Scoble, and we're at the AI/INFRA studio here at the AI/INFRA Summit in California. And AI launched in my house. A long time ago, Siri launched in my house, and that was the first consumer app to use AI. And now you're seeing a rapid change in AI. And I have a great guest on today who's going to talk to us about inferencing, because everybody's going to need a lot more inferencing in the future to run our robots and our autonomous cars. So, Vishal, tell us who you are. And my favorite question is, who are you? So who are you?
Hi, my name is Vasanth Mohan. I lead product marketing and developer relations here at Sunnyvale. And exactly like you said, the inference market's really hot, but the core of what everyone is really looking for today is, on the one hand, you have developers who want faster and faster tokens. The faster we can run these models, the better, and especially when models get really large. On the other hand, you have these inference providers that want to make money and need to have margins. And what underpins all of that is the hardware and the infrastructure. And where Salmanova was founded was really with this idea that there is a better architecture that can run inferencing workloads a lot better and more efficiently for a vast majority of AI models. And that's been the underpinning of everything that we've been doing at Salmanova. And I think the other thing is, when we look at data centers, and part of my talk at AI Inference Summit today is going to actually be the fact that when you run these data centers, it's not going to be a one-fits-all solution. You're going to have chips that are specialized for various different purposes. NVIDIA has kind of been the king and leading forefront of training these models. That there are places and purposes, even in the inference stack, that the GPUs can be used. But when it comes to really fast decode and really kind of the fast tokens that people care about, when developers and enterprises care about to build a lot of their agentic workflows or coding agents, that's where Salmanova really shines and accelerates. And I'm excited to be part of the journey of everything that we're building.
Yeah, if I was, a billionaire and building a data center, part of that data center has to be for making the model.
Mm-hmm.
Part of it has to be serving it out to millions and billions of people eventually.
Yep.
Using inferencing infrastructure like what you guys are building can dramatically change the cost of effectiveness of that data center, can it?
Yeah, exactly. And I think that there's multiple angles to that. So on one hand, it's like how many tokens that you can generate out of a rack. That's ultimately how you can bring that cost down lower and serving many more users. And where Salmanova really accelerates is we can reduce that overall cost for a lot of these agentic workflows. And that's been part of what we're really excited about with our upcoming SN50 chip. The other side of that also is just what we're seeing from the data center side is we're so energy constrained in running a lot of these AI workloads. And what happens when you move away from GPUs to RDUs from inference is that you can run a lot of your AI inference workloads way more energy efficiently. We're seeing all of the headlines right now around kind of the need for more water in data centers, more power in data centers. And that's actually more a result of just us running these AI solutions on the wrong hardware. When you deploy a Salmanova a rack into your data center, it can be run air-cooled on our SN40 chips, 10 kilowatts compared to what you're seeing on the Blackwells, which is north of 100 kilowatts for a lot of these workloads. And that's a 10x difference, which you can imagine is then 10x more GPUs that you could use for something else, right?
Yeah.
So it's on multiple vectors and fronts that we're seeing a lot of pressure for reducing the pressure on data centers, for energy consumption, the pressure on developers to reduce the costs for these agentic workflows. And it's picking and choosing the right chips that you use in the data center and how you build the stack from chips to models really smartly and intelligently to create a solution that can actually be deployed in production.
Yeah, let's talk about developers, because you have a whole developer story as well.
Mm-hmm.
You're inferencing a lot of these models for developers, and they're real happy because they're running fast, right?
Yeah.
What kinds of things are you doing for developers who might not be buying a data center or buying a rack in a data center, but need fast inferencing also?
Yeah, I mean, I think for developers, they want to get started really fast, right? So to actually do a full data center deployment takes months. Um, what we have to help people get started really fast is what we call Samba Cloud. You can go to it today at cloud.sambanova.ai, and we have a bunch of open source models that are available that are all running really fast. These are all independently benchmarked and running on our hardware. Minimax is an example of one of the ones that we see used a lot because it has a really great cost to intelligence ratio for coding, and it's really helping, especially when developers are running out of tokens on their favorite tool. They can switch to an open source alternative and offload a lot of their work to some of these open source models, get the answers really fast, and iterate way faster than they traditionally can just using any other bigger, larger open model that they might otherwise be using.
Yeah, I know developers who have like 3 Mac Studios underneath their desk,
Yeah.
you know.
Yeah.
Compared to doing local model on a Mac Studio, which is a $10,000 box, what's the speed difference when we're running on your chips? Because
Order of magnitude.
order of magnitude,
Yeah.
it's like it goes.
Yeah, exactly, right. Minimax, it runs insanely fast, right? Upwards of 300, 400 tokens per second on Samba Cloud. And you compare that to maybe the handful of tokens that you might get locally. The other interesting angle of that is actually the energy story. We had a report from Stanford published a few months ago at this point. And it was exactly to this point of comparing kind of the energy efficiency of running local models versus running things in the cloud. What they actually noticed running the workloads on our hardware was actually more energy efficient to run it in the data center as opposed to running it locally. The reason is because you can actually distribute that workload across many different users on the system, and you're generating the tokens way faster. So I think there is a world where you can have some workloads that run locally, some workloads that run in the cloud. And it really kind of depends on the specific use case that you have. Sometimes it's maybe less so an energy story. It might be actually more a privacy story that you want to run something locally. And even for that, we see a lot of enterprises that are coming to us and saying like, well, can we deploy your racks locally on-prem to solve the privacy issues, right?
Yeah.
So everyone has their own different use cases when it comes to things. Local is a really important story, and local can even make a difference even at the enterprise scale when they want to bring some of our racks onto their premises as well.
Yeah, we have about a minute left. With, you know, I just hung out with an AI science company here in Silicon Valley, and they're spending per person about $1,000 per day in tokens, right? So these companies now are hiring people who are, you know, $300 to $1 million salary, and they're expecting those people to generate that many tokens. What is that? What does inferencing in the cloud mean for that kind of team?
So I think the way I would think about it is we're seeing, especially on the frontier models, people spending thousands of dollars, right? I think it will end up looking like is actually you're finding you're going to need for a lot of these agentic coding solutions many different models for many different use cases. Even our teams today, they might use a really big frontier model for most of their work, and then offload a lot of their tasks to Samba Cloud running Minimax. Because it's a much smaller, cheaper model that they can use. And it's really, we're starting to move from the paradigm of using one model for everything, and rather actually using that model to train a smaller model with the prompts and the agent code to solve kind of specific tasks to help reduce your overall cost. And then you can also run those models really faster and then have them iterate much quicker using a solution like Salmonova. So we're starting to move into that motion. The bigger models, I think this really started only happening with Opus 4.6, have really gotten to a really good place where they can actually start doing some of those teaching loops and help create these distributed networks of smaller models. And that's ultimately where we see kind of the industry heading is kind of having one big planning model, creating a bunch of smaller models that are running really fast. And I think that the infrastructure that powers that is really, really important, and it's going to be the underpinning of what we're seeing happening moving forward in this agentic wave.
Well, thank you for joining me from the AI Infra Summit here. Where do people find out about you guys?
Head over to our website at summonova.ai. I'm pretty active on LinkedIn. If you just kind of quickly search me up for Vasanth Mohan.
Thank you so much.
Awesome. Thank you.